What are you talking about?
Good morning, everybody. Let's go ahead and get started. So today we're going to move on to another section regarding graphs of sine and cosine things today. They're actually pretty straightforward. I'll give you some templates and some equations to help you through them also. But I really want you to get this one down very, very well because the section after this is about more complicated trig graphs. And I do expect us to have a slight bit of struggle on that one. Okay, so let's review the basics before we do all this. Number one today, we're just doing what we always do. We're going to find the value of all 6 trig functions associated with this angle theta given in the picture. So here's our triangle, and here's the angle. Make sure you always look at the angle they're talking about. This is the angle. Don't use this one, right? If they're saying sines of thetas and stuff, you make sure you're looking at theta right there. But this is just SOHCAHTOA. What is by definition the sine of something? According to SOHCAHTOA, I'll put that on the board too. Opposite over hypotenuse. So what side's opposite this? It'd be the 4, wouldn't it? And hypotenuse would be the 5. So 4 over 5. That's simple. SOHCAHTOA is really not that hard. You just write it down. Cosine, let's see, that's by definition adjacent over hypotenuse, adjacent to the one next to it, which in this case would be 3. So 3 over 5. And tangent is opposite over adjacent. Opposite is 4, adjacent to it is 3. So 4 over 3. And there's the 3 basic ones. Which one is sine flipped? Do you know? Cosecant is, and it would be 5/4. Very good, everybody. Which one is cosine flipped? Secant, very good. So that'd be 5/3, and then cotan is the tan one flip, which is 3/4 there. So it's that easy. All you got to do is make sure you know which side's the opposite and the adjacent and the hypotenuse relative to the angle you're looking at, and that's all there is to it. Any questions over SOHCAHTOA at all? All right, let's move right along then. So, of course, it's not just about finding sides and dividing them. It's also about, points in space and arbitrary angles. So number 2 says find the 6 trig functions for this point, -5, -10. Now, you don't need a visual for this, but I'm trying to teach you what's going on here. This would represent over here at -5, 1, 2, 3, 4, 5, and down 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the point, -5 and -10. And it seemingly has nothing to do with trig. It seemingly has nothing to do with circles, but any point in space does lie on some circle. So the question is, what's the angle? Well, this would be the angle that they're talking about in question. Remember, you always start the positive x-axis no matter what, right? Always rotate this way. If I happen to land right there, then I happen to land right there. What do you need to solve these problems? You need the x, y, r stuff. Remember all that? This does lie on some circle with a certain radius r. And how do you find r based on x and y? Very good. Square of x squared plus y squared. You guys know what you're doing. So x is -5, right? When you square that, remember when you square things, they should always be positive, right? Make sure you're putting negatives in parentheses if you're doing it with your calculator or whatever. But -5 squared is 25. And 10 squared is 100. So grand total, that's the square root of 125, which I don't think is pretty. We could actually simplify this root a little bit. In fact, that's probably what they'd want you to do on your homework. I don't really particularly care, but there's a perfect square that goes into this. I'll simplify it a little bit more. 25 does go into this 5 times. So square of 25 is 5. So a slightly simplified version of my radius is 5√5 there. So be thinking about that. It'd be good practice to try to simplify your roots if you can, because we did a whole unit on that, so it shouldn't be a skill that we can do. Okay, so we got the r, we got the x, we got the y. How do you find all those based on that? Well, I always in my mind quickly think of a little triangle here with sides x, y, and r. And if I can know that picture in my mind, then I know all the other 6 extended definitions. Because sine is opposite over hypotenuse, so on this picture, that'd be y over r, correct? And cosine's adjacent over hypotenuse, that'd be x over r, and so on and so forth. So the sine of this angle, whatever it is, you don't even need to know what it is. If there's some angle associated with this point, is going to be opposite over hypotenuse, that's y over r. So in our case, that'd be -10 over this weird 5√5 thing. So -10 over 5√5. And you should try to simplify things a little bit if you can. At least for me, like 10 over 5, that's just 2, right? So we could call this -2 over 5. And I'm okay with that answer. The online curriculum might not be if you're putting things in electronically. They might want you to get rid of roots on the bottom. And to get rid of roots on the bottom, what do? You multiply the top and bottom by that root. And then on the bottom, the square root of 5 times the square root of 5 is 5. So that's like the best answer right there, is something like that. Questions over any simplifications for that? That was just a lot of tedious algebra stuff right there. Okay, similarly for cosine of an angle is adjacent over hypotenuse, according to my little trick up here. That looks like it's x over r, correct? So x is -5. And again, r is 5 root 5. So you see there's a 5 on a top and a bottom. So they're going to cancel out, leaving you with a -1. Make sure when you cancel things out that the root's still on the bottom. If the root was on the bottom, it's still on the bottom. I see a lot of kids, it's cancel out, and they'll just say the answer is square root of 5. It's not, because the square root of 5 is on the bottom. And that's a fine answer. I would take that. But again, your online book might not want roots on the bottom. So even better answer would be negative square root of 5 over 5 after you rationalize that thing. And so on and so forth. Tangent. What's tangent? Opposite over adjacent. That would be y over x. So that'd be -10 over -5, which is just 2. So that one was easy. And we go to all 3 of the main ones. So let's do the other sister functions. The one that goes with sine is cosecant. Flipping this, let's see, where's a good place to flip this? I could flip this, but then the root would be on the bottom, right? And I have to deal with it again. Right here, didn't we already have the root on the bottom right there? If I flip it at this stage, then the root will be on the top. So how about -√5 over 2? That's what that was. We'll flip it right there. Secant, that's the one where you flip cosine. So let's see. I don't want to flip this one, then the root will be on the bottom. I could, then I got to clean the root again. But right here, we had a -1 over √5. So if I just flip it right there, that'd just be -√5. And lastly, cotan, that's the one where you flip tan. And 2 flipped, since 2 is 2 over 1, would just be 1/2. So a lot of simplification there. And I see a lot of people when they're doing their homework, they see the sides of the triangle and it's not in the answers, and they're confused. Like, oh, this side's 6, and this has a 3. Why is there not a 6 and a 3? And it's probably because things are reducing and they're simplifying things. So make sure you are doing that along the way. Cool. All right. Lastly, what if they just give you a weird angle? They don't give you a point. They just say for this angle, and number 3 gives you an angle of 540 degrees. How do you go find all 6 trig functions for that? Well, if you have an angle given to you, this is the time you bust out your unit circle. And you try to look for 540 on your unit circle, but it's not there. What do you do when you have an angle that's not on your circle? You find something that is on the circle. Very good. Subtract. Yeah, why not? Anything. What's that called when you add or subtract? It's got a fancy word. Coterminal. Yeah. I can always add and subtract 360 and get to the exact same spot. It has the same meaning. So we're going to do that. As outside the range, I'll subtract 360, and I believe that turns into 180. So I'm really just trying to find things for 180. Well, go to 180. And at 180, the coordinates are nice and simple. What's the x value on your unit circle at 180? And what's the y value? And for your unit circle, r is always, yeah, very good. So you got some nice clean numbers to work with when you're doing this. It ain't going to be so bad. So let's see what we got. Sine. The original problem was 540. I'm going to still write it as the original angle, even though we know it's the same as 180. They didn't ask me about 180. They asked me for 540. So sine, again, if you look at your little cheat sheet up here, sine opposite over hypotenuse. That's y over r. That'd be 0 over 1, which is just 0. So sine 0. Cosine of 540. Or my little cheat sheet up here is adjacent over hypotenuse. That'd be x over r. So that'd be -1 over 1, which is -1, correct. And tangent, let's see what tangent would be. Tangent of an angle is always opposite over adjacent. My cheat sheet says that's y over x. So I'd have a 0 over a -1, which again would be 0. So that's nice. Now, this is very important, especially going to the graphing stuff very soon. When you flip these things, what's 0 flipped? Not really. Because 0 is 0, like say 0 over 1, right? If you flip that, maybe 1 over 0. Can you divide by 0? No. Whenever you're trying to divide by 0, you cop out and you just say it's undefined. Doesn't make any sense to divide by 0. So some of these are undefined, which on a graph, you know what happens on a graph whenever you divide by 0. What happens when you divide by 0 on a graph? It has a vertical asymptote. So next lessons, when we start talking about graphs of cosecants and things like that, you might see some vertical asymptotes of this stuff. Okay, let's flip the cosine to get secant. -1 flip is still -1. And same argument for the tan. If you flip that, cotan can't flip a 0, can't divide by 0. So that one would also be undefined. So there's all that. Questions over those 3 basic skills we've been practicing to death. SOHCAHTOA, point out in space, or just an angle given. They're all the same thing that we just keep doing. But those are the 3 main skills that you have to get at the bottom level of the trig to go up higher. LGs today, here we go. Learn how to graph and analyze sine and cosine functions. And maybe model some real world situations, some other education nonsense things. You don't have to have this handout I'm handing out right now, but it doesn't hurt. Especially if you're going on a pre-calc, this would be like your baby. Hang on to this thing. This is by far the best handout I've ever created. I love it. I'm very proud of it. It took me 5 hours in Paint. That's right. I use Paint. Microsoft Paint. Now, your job is not to memorize this thing, but it's a good reference of what the basic shape of the graphs will look like and things like that. And again, if you are going on a pre-calc, you will use this thing to death to solve problems. James nods and agrees.
Yes.
So it is a great handout right there. It is posted online for remote people. So in today's lesson, there's a handout that says trig graphs. And that's all there is to it. Homework 11.2 is due today. It was really over a couple sections. I just said it was 11.2, but the unit circle stuff, that was 11.3 also. Don't worry about that. It's due today. So 3 through 45 multiples of 3. Please jot down the next one. That's due on Friday. I don't think you'll have too much trouble with this one. But still, I want you to go nice and slow through this and get the basics down, because we're going to need those in the next section when things get a little crazy. We're doing section 11.4 today. Moving on, skipping 11.3. That was kind of already encompassed in the last lesson. And this lesson is just 1 through 16, period. No odds, no evens, just all of 16 problems. Very straightforward. Due on Friday. You'll have a work day tomorrow and all that jazz. And here we go on the main stuff. Section 11.4 is entitled Graphing Sine and Cosine Functions. Found on page 565 of your online textbook, or 585, excuse me, of your online textbook. And you just got to get some basic terminology down and the basic shape of the graph. It's really not going to be that complicated, but you'll have to take good notes and refer to them a lot, because I'm trying to spell everything out for you in just a few equations of how things work. First things first, I'm trying to summarize this entire slide in this box down here. These are the main buzzwords we're going to be using this lesson down here. Something called a midline, something called an amplitude, something called a period, and something also called a frequency.
You can't figure out what to do with a midline. It's called a midline crisis.
That was recorded, James.
Oh no, I'm sorry.
Your terrible joke will be saved for posterity.
Okay.
Everybody judge James. There we go. Ha
I guess this is how I'll be remembered.
That's right. It's going in the senior video.
That'd be awesome to just cut to like some names.
By the way, I got a few seniors in here, don't I? Yeah, I'll have to check warmth and learning goals sometime, and then The end of the week is really your last time. So tomorrow I will be checking warm-ups and learning goals for any seniors, just seniors. Okay. If not, then you got another week or so, but heads up, tomorrow, seniors, I'll check warm-ups and learning goals. Easy 50 points if you've been doing them all semester long.
How we need to do these recap components and stuff.
Until you see a graph of sine and cosine, these terms don't make a ton of sense, but as soon as you do, it'll make good sense. But you have your handout in front of you. You can already see from looking at your handout that I just gave you that there is like a middle of the graph. There's a line that goes right through the middle of it horizontally. That's called the midline. Amplitude is about how high it goes. So they're all going to be wavy things, as you might see on your handout. They go up and down, up and down, up and down forever. Why? Well, we'll talk about that really quickly. And how high they actually go is what's called your amplitude. Your period is more about how a horizontal distance between cycles. So you can have one that goes really, really slow and it repeats every 2 or every 4 or something like that. Or maybe something goes really, really fast and it repeats every half of a unit or something like that. And frequency is just the inverse, the reciprocal of period. That's all you got to remember about that. They're really simple, but until you see some graphs of just talking nonsense. They all have letters associated with them. Please know the letters for them. Amplitude is going to be capital A. Period is going to be capital T because it usually stands for a time that takes for something to repeat. And frequency will be lowercase f. All right, let's see what the heck this stuff is really about on a concrete level. First thing you need to do is jot down the basic sketch of what these look like, okay? And I'm going to go kind of off script on this for a second. So let's think about why these graphs are what they are. On your unit circle, let's talk about sine. We've alluded to this many times, but the definition of sine extended is y over r. Now, if you're on your unit circle, what's r? 1. So on the unit circle, the sine of whatever angle you're talking about is just the y value. Fair enough? So walk along the circle with me. We're going to start right here at this point, and we're going to rotate around, and you tell me what happens to y. What's y right there? 0, isn't it? So guess what a graph of sine starts at? It starts at 0. Then what happens to y as you rotate? Y is getting bigger, isn't it? And it gets all the way up to here. Now, how high can it go? This is 1, right? Unit circle. So the biggest y value gets up to is 1. Are you down with that? So it kind of climbs up and it goes up to 1. And then as you rotate farther, what's happening to y? Camera's gone? Yep. Thank you. As you rotate around, what happens to y? It's not 1. It starts going back down, doesn't it? So now it's going back down, and now it's back to what? 0 again. So it goes back down to 0. And then y starts going negative, doesn't it? And it goes all the way down to -1, doesn't it? So then it goes down to like -1. And then finally, when you get back up to here, it's back to 0. And since you're back where you started, what's going to happen if you go around again? It's just going to do it over and over and over and over. And that's why a graph of sine basically looks like this pattern repeated indefinitely right there. So one note for yourself is sine. One thing to know about it is sine starts at 0. You might want to write that down. Sine starts at the origin every single time. That's always what sine's going to do. This is the basic shape of a sine graph. It looks like a wavy thing like that. Cosine, on the other hand, by definition, is x over r. And again, if you're on your unit circle, then r is 1, so the cosine is just the x value. So I'm going to do the same thing, but you tell me about the x values this time, not the y's. What's the x value right here on your unit circle of radius 1? So cosine doesn't start at 0. It starts up at 1. And then what happens to the x value? It's getting smaller. Would you agree? Right here, the x value is 0, isn't it? So it goes down. Then the x value is 0. then the x value starts being negative, doesn't it? Until you get over to here at -1, right? So it goes down, it becomes negative, it goes down to -1. Then the x value starts getting, it's still negative, but it's getting closer back to 0. Wouldn't you agree? So this heads back up to 0. And then finally, the x value is positive again, correct? And it gets back to where it started at 1. And then what's it do after that? It just keeps repeating indefinitely. So where does cosine start? That's your other note. Cosine starts at 1. By far, this shape is what you need to understand. The sine and the cosine both have the same shape. It's just one wave. And you need to know that sine starts at 0 and cosine starts at 1. If you know that, you're going to be just fine. The midline. It means what you think it might. It's the line right through the middle. So by default, for these, where's the middle? It's just where y equals 0. Wouldn't you agree? Okay, so maybe make a note to yourself that the midline for both of these is y equals 0. Of course, they're going to have some problems when they have a +5 on the end or a +6 on the end. And you know what that does? It just scoots things up and down, right? So the midline doesn't always have to be at 0, but by default for the parent function, it is this right here. The amplitude. I think I got notes over this actually. Why explain it 8 times? Here's the last thing you really need for the day, and you can just take a second and jot down because it's got all the equations and the ways to find things. In general, when you graph something that is based on sine or cosine, they lump those two together and they call them a sinusoid. So a sinusoid is a fancy word for basically a sine or cosine graph. Again, it's got the graphs right there. Sine starts at 0, cosine starts at 1. Now you know why. It's just based off the unit circle and just goes around and around and around. If you have a sinusoid, any equation of these two forms up here, either one, sine or cosine, same thing. They just start at different places. The amplitude, which is how high it goes, basically, how high above the midline it goes, is just the letter in front. Just the letter in front. I should actually say it's the absolute value of that, technically. Maybe I should fix my slide or something like that. You might want to put an absolute value symbol around that A, because if it's negative, that doesn't change the height of it at all. Your amplitude just means how high it goes above the midline. That's all it is. How high does it go from the middle to the top? And if you look at the normal sine graph, it normally goes, the middle is at 0 and the top is at 1. So by default, your amplitude is 1. They don't have any number in front, then their amplitude is 1. But you know what happens when you take a function and multiply it by a number? It stretches it, right? So if there's a 6 in front of your trig function, it makes everything 6 times bigger, which would make the height it goes up to, the amplitude, 6 times bigger as well. That's why if you need to find the amplitude, how high this thing goes, you just look at the number in front of the trig function. Your period, how often does it repeat? Well, how long does it take to go all the way around a circle, guys? How many angles are there all the way around the circle? 360, yeah. So normally, it would have a period of 360. That means how long it takes to repeat. Or in radian mode, what's all the way around at 2 pi. So you see these equations here for the period have 360 in them and 2 pi. Of course, if you multiplied your x by something, like the b there, b times x, then what would that do? Whenever you multiply your x by something that's a horizontal stretch, right? That could shrink it down or expand it. The period could be different. That's why there's that little correction factor of divide by the absolute value of b right there. If there is a d on the end, then that just moves things up and down, correct? So that moves the midline up and down. So your midline is whatever y equals d. And your frequency is just 1 over your period right there. Other key things to know about this is, for any of these graphs, the zeros or the humps or the extrema all happen a quarter of the way through the cycle. Now, let's talk more concretely about this. let's look at the picture we have right here because this picture says a lot more. First off, what's the midline mean? It's the middle, right? Okay. By default, that's at 0. Amplitude literally means how high the graph goes. Okay, so if I gave you a graph of sine, something like this, that's a 7. How high is this graph? Don't tell me it's the whole thing. It's the distance from the middle up, which would be 7. So this thing would have an amplitude of 7. Another one that would be very similar. Let's say you had this one right here. What's this guy's amplitude? 2, because that's how high it goes above. So that's all amplitude means. It just means how high up and down does this thing go. And period is how long it takes to repeat. Now, if you look at this graph, here we go. We start at 0, right? We go all the way up and we came back to where we started. Now, do you do the exact same thing after this? Do you just keep doing humps? No, you're not done yet. A period is a whole cycle, which would be starting here and coming back to right there, 0, this one, right? And then it goes again, and then it goes again. The period is how long that takes to happen right there. Any questions over what a midline is?
No, but the amplitude, is the amplitude like 0 or is it from the midline?
It's from the midline. Yeah. The distance from the midline to the top. So basically half the total height. Okay. If the total height's what? This is 1 and this is -1, then the total height would be 2, wouldn't you agree? And half of that is 1, right? So it's half of the total height every single time. That's all you got to do. But in an equation, all you got to do to find the amplitude is do what? Just look at the number in front of it, right? It's got the a in front, and that's kind of all there is to this stuff. Also note the last part of my little thing. It said zeros or extrema occur every 1/4 of the way through a cycle. What the heck is that talking about? You should see that each of these have 4 distinct parts to them. That's an extrema, would you agree? That's a 0, would you agree? That's a minimum, would you agree? And it starts all over again, and I'll just say this right here. Notice this cycle is broken into how many parts? 1, 2, 3, 4. Every time you go 1/4 of the way through a cycle, something interesting happens. You start at 0, that's interesting, right? That's an intercept. Then there's a max, correct? That's interesting. Then there's another 0, right? Then there's a min. Then there's a 0 again. So every 1/4 of the way through of these all the time, you will always have something interesting happen, either extrema or something like that. So let's look at some practice problems now. Here we go. Example 1. Just identify just from the graph what the amplitude and period is. Now, what's the amplitude? It's either half the total height, right? Or the distance from the middle to the top, either one you want, correct? All right, well, the middle looks like it's at 0, would you agree? And the top looks like it's at, I don't know, 4? 4, what do you think, 4?
It says 4.
Does it say 4? Oh, it does. Okay, 4. So the amplitude would be 4, because that's the distance from the middle to the top, right? Where's the midline? I think the middle would be right through the middle here, which would be probably what, y equals 0, that equation, y equals 0? Cool. What's the period? That's how long it takes to repeat. It's always good to start at 0. Here's 0, right? I'm going to go through a whole cycle, and you tell me when we get back to where we started. Oh, right here, right? So how far is it from 0 over to pi? It's pi. This thing's period would be pi. That's all there is to it. Any questions over that one? Okay. How about this one? What do you think the amplitude of this is? It is 2, yes. And the period, I would start at 0. It starts high here, doesn't it? So tell me the next time it gets back to being high again. Woo, and you're right, it looks like it's at 60. So this thing's period, t, would be 60. Very easy to spot on the graph when you kind of agree. Nothing too tricky here. You just got to know what the things mean. And the midline would be right through the middle, which I think, again, looks like y equals 0. Yeah, so nothing too tricky about that. Okay, let's see if we can do one where they give you an equation. Let's actually write this one down. F of x is 3 cosine of 5x. How do you graph something like this from scratch? The first thing you should probably notice is this says cosine, correct? What should pop to your mind when you think of a graph of cosine? You should think of something that starts high, right? Doesn't start at 0. Sine starts at 0, right? Cosine starts up high. So I'm thinking it's going to look kind of like this-ish. Fair enough, like a cosine graph, because it's a cosine graph. How do you start finding all these things for this? Well, let's go back to our little cheat sheet here. This is what this is your baby for the day. Okay. How do you find the amplitude? It's the number that's in front of it, correct? So for us, that would be 3. Write down A equals 3. We'll just write down every little thing about this, then we'll put it together in a second. Amplitude is 3. What about midline? How do you find the midline? Well, the midline is just y equals whatever is on the end, because that just moves things up and down, correct? Now, is there anything on the end of this function? I don't see any plus things or minus things, do you? So it didn't move up or down, which means that the midline's at y equals 0. Write that down. There's no good letter for midline, so I just write it out every time. Y equals 0. Now the tricky one is the period. It's not that tricky. Let's see here. They're using degrees. Do you have to use degrees? No, you can use radians. Sometimes they'll use radians, sometimes they'll use degrees. But the equation for the period here, if you look back on your thing, is it's 360 over the absolute value of b. Fair enough? B represents the number that is in front of the x, right? What number is in front of your x? 5. So your period will be 360 divided by the absolute value of 5, which is just 5, right? So let's see what that turns into. Your period is 360 divided by 5, which turns out to be gross. Yeah, 72. What a bad number. Now, based on all that, writing down all the things for the day. By the way, there's also frequency. You're not going to use that much, but they ask you for that. It's just 1 over your period. So if your period was 72, it'd just be 1 over 72. It's a stupid little extra calculation. You just always take your period, just flip it, and then call it your frequency. All right, what the heck does this thing look like now? Well, this is a graph of a cosine, correct? So let's start building this thing up. Cosines start high, right? Now, how high? Normally 1, but the amplitude is not 1. It's 3. So you need to start not up at 1, but 1, 2, 3. And guess how low it will go? It'll go down to -3. After this, it's probably a good idea to deal with your period, because your period is how often it repeats, correct? So it should go through an entire cycle, which would be going all the way down and back up. And I'll just kind of draw something like that. But I dang well better, and this is what I'm looking for when I'm grading. If you say your period's 72 degrees, then when I look on your graph and I see that little thing go up and down, I should see it get right back to where it started after 72 degrees. That's a rough sketch of this thing. The midline, I'll draw the midline just for completeness. It's right through the middle, right? At y equals 0. Amplitude's 3. Also, key points on here. Interesting thing happened every 1/4 of the way through this thing. Might be a good idea to take your period and divide it by 4. Can somebody do 72 divided by 4 for me? 18. That means every 18 degrees, something interesting happens. Right here, that's something interesting, isn't it? It's a 0, right? Guess what happens at 18 degrees? If you go another 18 degrees, which would put you at 36 degrees, something else interesting happens. You have this little minimum right here. If you go another 18 degrees, which is what, 54? Something else interesting happens. This little minimum right here. Or not minimum, I mean 0, excuse me. And then if you go another 18 degrees, you get right back where you started at 72. Do you see how something interesting happens every 1/4 of the way? That's important, okay? Especially building onto this for next section. We're going to need to know where zeros are for things extremely importantly. Okay, so they ask you for x-intercepts. What would you tell me the x-intercepts are? Where's across the x-axis? Look at the picture. 18, right? And 54, correct? If they asked you for an extrema, I'd say that there's a local max at, where's this max at? It's at 0, right? Or you could say 72. Could you just keep saying things? Yeah, you could. We'll talk about that more in detail later. And there's a local min at 36, correct? So you have all the things you could need to analyze this thing. And that's kind of a rough sketch of what this would look like. If you put it in your calculator, this would look like that right there. Questions over how we did that one? Okay. Let's try some other ones then. How about this guy? Let's see if this graph looks accurate. Let's see how they constructed it. First off, what's the number in front? It's 0.5, right? That's your amplitude, right? So that means this thing should only go 0.5 high, does it? Yeah, we're good. Why does it start at 0 right here at the origin? Because it's a sine, exactly. And the period, well, how often does it repeat? It looks like every 90. How would you get that from the equation? Well, your period's 360 over b. b was 4, right? And guess what 360 divided by 4 is? It's 90. So right here at 90, it starts repeating. And then every fourth, if you were to divide 90 into fourths, there'd be the top, there'd be the 0, there'd be the minimum, and then there'd be back to the 0. Questions over anything? Are you sure? Going a little fast, but are we okay? All right. Now, let's just see which graph of these would probably match this thing. What's the amplitude? Don't tell me, yeah, sure. Don't tell me it's -2. It's always positive. In fact, if you need to write that down, maybe make a note to yourself, amplitudes are always positive. The negative tells me something else. What does a negative do in front of your graph? It flips it, yep. So I'm going to start looking for a graph of sine kind of upside down. Sine starts at 0, correct? Which of these starts at 0? A does, right? Does B start at 0? No, I can cross that out. Does C start at 0? Yeah. Does D? No. So right off the bat, I know it's either going to be A or C. Now, sines usually start at 0 and go up, correct? But if it's a negative in front, it's going to flip it. So it's not going to go up, it's going to go down. But A and C both do that, don't they? So that didn't help me any. What's the period of this thing? The period is 360 divided by 3. That turns out to be 120. Which of these repeats after 120? Let's see. Does this one repeat after 120? Yeah, it does. Does this one repeat after 120? Am I right back where I started? No. So your answer for this one would be A right there. Yeah. How about this thing? Let's do it real quick. Do you buy this as the graph of a cosine? Does it start high? Yeah. Does it start up at 2 where the amplitude is? Yes, it does. Goes all the way down to -2. And the period would be 360 over 3, which is 120. Let's see if it repeats every 120. Here, it starts high, goes back up here. Do you buy that right here is about 120? I do. So yeah, it might make sense there. Let's try this one. How would you graph this? Let's write it down. Let's actually do this one. They didn't give it to us, so we'll do it. Not hard. Not hard. Negative cosine of something. And we know that. So what's the amplitude? What number is in front of your cosine? A 1. Right. So your amplitude is 1. Yeah. Amplitude's 1. What else is there to this thing? Well, how about good old midline? Where's the middle of this thing? I don't see any number on the end to move it up and down, do you? So again, it's just going to be the boring one of y equals 0. And if I want to find the period, the equation for the period is 360. Or in radians, it would be 2 pi, correct? Okay. They're going to be some in radians, so that's not always 360, but it's all the way around divided by b. In our case, b was 2. So this thing will repeat every 180 this particular time. And if I want to find the frequency, not that they're going to ask that too much, it's just 1 over your period. So that'd be 180. You don't really use the frequency to do the graph. It's just like a side thing. I'll find the frequency. Okay, there it is. All right, what's the graph that's going to look like then? Well, it's going to look like a cosine graph, correct? But there's a negative in front. So it's going to flip it, correct? So it won't actually start up here and go down. It'll start down and go up kind of thing. And how far down will it start off? At -1 because the amplitude is 1, right? It's going to start low and make sure it matches what you said. You need to go find on your graph wherever it says 180 And your job is to make this thing repeat. You guys draw it right. To make sure that it starts here, goes all the way up, and comes right back to where it started after 1/8. That's what a period is, right? Starts to repeat. So something like this goes all the way up, all the way back down, and then it would start all over again, wouldn't it? So this is a rough sketch of it. The midline would be right here, right through the middle. It repeats every 180. And other interesting things. Can't emphasize this enough. The interesting things on this graph all happen a fourth of the way through. I'll save you the time. A fourth of what 180 is 45. So this one will happen at 45 degrees. This is 0. This hump will happen at another 45, which is 90. This 0 will happen at 45 after that, which is 135. And you add 145, another 45 to that, you get back to guess where? 180, and it starts all over again. I think it's making perfect sense. I'm sensing you guys get it. You think you guys get it? I think you do for the most part too. Let's see if they got anything else interesting today. Not really. Application, you don't care about that, do you? Okay. All right, so there's your main things. Midlines, amplitudes, periods, frequencies, and drawing them. It's pretty straightforward, but take your time. Okay, make sure your periods are accurate. Make sure you figure everything out. Use those equations we talked about. And don't forget that 11.2 is due today. Work day on this stuff, 11.4 for tomorrow. Have a good day, everybody. Yes.